Typically, gravel sand fraction finds F200, Cu, Cc, liquid limit, plastic. These parameters are needed to classify the soils. So now we're going to use unified soil. We're going to learn about the unified soil system. So this is an example that I mentioned. CH, the result of the classification at the end, what we're going to see is a USCS classification. For example, CH fat clay. So we're going to come up with a group name and group symbol combination. The combination of group name and group symbol is essentially the first letter. So it could be gravel with G, sand for S, M is for clay, and O for organic. So for group symbol, the second letter, it could be a poorly gravel or sand. W is for well graded, H is for high plasticity, and L is the low plasticity. These two correspond to and silt actually. So these two charts in the next page, and then we will try to understand. Now we have, for unified soil classification system, this is USCS again. We have this number one. This flow chart is used for the soil that is fine grained. When we have fine grained soil, that means 100 is larger than 50%. If the soil is coarse grained, we have another, which is in the next page. For coarse grained soils, when we have F200 less than 50%, then that's a coarse grained soil. Then we use this particular chart. So let's look at that particular example that I gave right there. So the one on the board right there. So what do we have here? So what we have is F number 200 was 15%. F number 4 in that example was 28%. I also said liquid limit is 40 for the material passing number 200 sieve, and plastic limit is 30 from these two. So for this soil, this is actually all information we need at the moment. Since we have grain sizes, we can calculate C sub C and C sub U later if needed. But let's just stick with this for a second. So let's start with which graph we're going to use to classify the soil. First thing we look at is F200. F200 says we have 15% passing number 200 sieve. I'm looking at here, this graph applies. This graph does not apply. Okay, so I'm choosing this particular graph or flowchart. So now let's look at whether the soil, now we are beginning here, so we need to go either up or down. So we need to figure out whether we have more sand or more gravel. This says if the percent sand is less than percent gravel, we're going to go this way. If the percent sand is larger than percent gravel, we're going to go this way. So percent sand, it is F number 4 minus F number 200. So in this case, 28 minus 15, that is equal to 13. So percent gravel, 100 minus F number 4. So 100 minus 28 is going to be 72%. Clearly, percent gravel being 72 greater than the percent sand, we're going to have this, because mostly gravel. This particular soil is mostly gravel. So let's look at next. Next question is, what is the percent passing number 200 sieve? It is 15%. So this particular path applies 12. So we go here. So now next is a critical. Now we need to find the group name and symbol at this level, at this point. So now in order to find that, what we need is we need to look at another figure called figure 5.3, which is in page number 12 in your notes. So now I need to figure out whether this soil is the fine content or fine portion. This is the fine portion. The fine portion, meaning the material passing number 200 sieve, that whether it's an ML or MH, CL or CH, or CL or ML. I need to. So how do I find that? Using this, what we call plasticity chart. This plasticity chart is based on liquid limit plasticity index. So the horizontal x-axis is liquid limit and vertical plasticity index. Please caution, this is not the plastic limit, this is the index. Plasticity index is liquidness plastic limit. In our example was 40, plastic limit was 30, so the plasticity index is 10. So depending on the plasticity index and liquid limit combination, in this case, plasticity index is 10. I draw a horizontal line, and liquid limit is 40. I draw a vertical line at 40. So intersection is this point. This area corresponds to ML. So this soil is an ML soil. Is this clear? Okay. This is an ML soil. Since this is an ML soil, this one applies. So now we have a group symbol. So this is a GM soil. By the way, it is not an ML soil. ML is the fine portion. The whole soil itself is G. Okay? So ML is only the fine portion. We're talking about the whole entire grain size, as you see from the on the board. This is a GM soil. Silty gravel. So let's go back to notes. You have M is silt, G is gravel. This is actually a silty gravel. We are not done. We have 2 more steps to go. So so that we can write down whether silty gravel or silty gravel with sand. Let's the amount of sand in it. If the percent of the sand is less than 15, we go this way. So percent sand is 30. So this one applies. So it is indeed less than that. And that means the answer is silty gravel. So the answer is, this is a GM soil, comma, this is a silty gravel. M stands for silt, G stands for gravel, silty gravel soil. Any questions? Yes?
How would you end up with the CL-ML?
This is CL, I mean this one?
Yeah, how would you end up with that?
So in that case, so this is the area that corresponds to CH-LML. So you might have a 20 liquid limit and maybe like a 5 of a plasticity index, then you would get in there. Yeah, it's kind of hidden there, right?
Yeah, in this entire thing.
Any other questions? Okay. Okay, so these are pretty straightforward subjects, so I'm gonna move on. So as I said, all you need is liquid limit, plastic limit, CU, CC. In this case, we did not use the CU or CC. So we could have used them. So if you end up going this route, you see at some point there's CU and CC. There's a question about CU. Okay? So in this particular example, I didn't need it, but you might need the CU and CC. As I said, once you have the grain size distribution, you have CU and CC, and you're done. So the second classification system is the AASHTO classification system, very common. We use this typically in pavement payment construction, payment base, subgrade. Ash to classification system, same types of parameters are used. In this case, we do not have a flowchart, but we have a table, a relatively straightforward table. So if you look at the types of classification, so the soil can be an A1A, A1B, could be an A3, could be an A24, A25, and so on. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have 12 different combinations of soil based on ash. So the way that we do this, it's usually a process of